Hi, I'm Mariah Schrum.
I'm Michael Johnson.
And I'm Ghuy.
And we will be presenting on our paper, 4 Years in Review, Statistical Practices of Likert Scales in Human-Robot Interaction, co-authored by Dr. Matthew Gombolay. Before we dive into our findings, we want to begin with a motivating example showing why the field of HRI should care about employing statistically correct practices. In 2015, a study was conducted by Novak et al. In which research groups attempted to replicate 100 different psychology studies. Only 36% yielded significant results compared to the original 97% that found significance. The results from this study caused many in the scientific community to call into question the integrity of psychology as a field. The study even caused the field to be criticized in the news media, with sources such as The Independent saying, "Study reveals that much of psychology research really is just psychobabble," and Vox's story titled, "Psychology is in Crisis. This scientist's striking confession explains how we got here."
The field of psychology was accused of p-hacking, poor study design, and generally producing unreproducible results. We as HRI researchers do not want to see the field of HRI in the same situation several years from now. We believe that we need to adhere to the best statistical practices so that HRI continues to be a leader in how we design robots.
Psychology is an integral part of HRI, where many subjective psychological measures are often applied to robotics research. Examples of psychological constructs often measured in HRI include trust, sociability, and perceived intelligence. One specific tool taken from psychology field that is heavily employed in HRI are Likert scales. In our review, we choose to focus on Likert scales and associated data because of its prevalence in the field and the widespread confusion surrounding their use.
Likert scales were developed by Rensis Likert in 1932. A Likert scale is composed of a set of items in which the participant must choose a rating on a response scale, typically between strongly disagree and strongly agree. These responses sum to a composite score that quantify the attribute in question. When we first started as HRI researchers, we thought that Likert scales seemed pretty straightforward.
Yet, there are many choices that come into play when constructing and analyzing Likert scales. Is the data ordinal or interval? Should we use parametric or non-parametric tests? How many response options should we include? How many items? Should there be a neutral option? Should the scale be balanced? The list goes on.
To address these many questions, we first conducted an exhaustive review of the best practices in psychometric literature. We investigated Rensis Likert's original work, as well as studies and simulations that have been conducted since. We also note what are considered established best practices in the psychometric field. We investigate the proper terminology, proper design, and correct statistical testing of Likert data. We then reviewed the last 4 years of HRI papers to determine the extent to which Likert data is improperly utilized in the field. Based on our psychometric literature review and review of the past 4 years of HRI, we provide a list of recommendations to the community. Our goal is not to disparage the field, but instead open the door to a healthy debate about how we can improve the way in which we employ and analyze Likert data in our research.
When conducting our survey of the last 4 years of HRI papers, we reviewed papers that included the terms Likert, Likert-like, rating, scale, and survey. We review papers for misnomers, improper design of Likert scales, and improper application of statistical tests.
We found that over 50% of papers in HRI utilized Likert data, resulting in a total of 110 papers in our review. Of these, only 3 properly designed and tested Likert scales, and we found that the error trend was not improving over the years.
We present our results for the various ways that the term Likert was misused throughout the papers we reviewed. We found one of the most common misnomers to be referring to the response scale of a single Likert item as a Likert scale, with nearly 30% of papers making this error. We also found it common for papers to refer to semantic differential scales as Likert scales. For more information on the difference between semantic differential scales and Likert scales, please refer to our paper.
Focusing on the most common misnomer, we will now discuss how to rectify the confusion relating to the use of the term scale. Likert scale refers to a set of Likert items, which sum to a composite score. However, this term is often misused to refer to a single prompt scale from strongly disagree to strongly agree. The proper term for this type of scale is a response scale or response format. This is an important distinction because misuse of the term may lead readers and reviewers to believe that there are multiple items in a scale when in fact that is not the case.
Within our survey, we found various errors related to the design of Likert scales. These errors included having an insufficient number of Likert items within a scale and failing to report Chromebox alpha to show internal consistency of items. Several papers also did not report sufficient information about the scales that they used, making it difficult to verify the legitimacy of their analysis.
As we have already stated, the optimal number of items is a common point of confusion in terms of scale design. Simulation studies from the psychometric literature have shown that a single item is not adequate for measuring a complex attribute. In HRI, most of the attributes that we measure, such as trust or perceived intelligence, are considered complex, multifaceted constructs. Therefore, as we determined from our psychometric literature review, multi-item scales with at least 4 items are most appropriate when measuring such attributes.
When reviewing papers containing Likert data, we found that papers commonly made the following errors related to statistical testing. Many papers performed parametric tests on single Likert items, and over 50% did not check for assumptions when utilizing parametric tests. We also found that a portion of papers did not apply a post-hoc correction when analyzing individual items within a scale.
When deciding the type of statistical test to use, we recommend that researchers first ask if the scale is a single item or a multi-item scale. If it is a single item scale, err on the conservative side and assume that the data is ordinal, then apply non-parametric statistical tests. If analyzing a multi-item scale, assume that the data is interval. Then, check to see if the data meets parametric test assumptions. If it does not, again, use the appropriate non-parametric test. If it does, use a parametric test.
And so, we conclude by sharing once again the main recommendations presented today. We recommend that researchers employ the term response format or response scale when discussing the scale from strongly disagree to strongly agree, and to reserve the term Likert scale when referring to a set of related items which describe a single attribute. A single Likert item should not be used as a sole measure for a complex attribute, and based on our psychometric review, we advise that researchers utilize scales with at least 4 items. Lastly, we ask that researchers take into account the ordinal nature of the data when applying statistical tests to single Likert items. For our full results and a complete list of recommendations, including scale balance, neutral options, post-analysis, and more, please see our paper, 4 Years in Review, Statistical Practices of Likert Scales in Human-Robot Interaction.
And as we end this presentation, we must reiterate that we have not always employed best practices in our own prior work. We provide these recommendations in the hope that they improve our work related to Likert data, as well as the community as a whole.
Thank you.